Oh, hey everybody, welcome to Tutor Justin, where we take AI to the next level in your educational journey. This will help students, this will help teachers, this will help professors, this will help friends that are helping out students, this will definitely help tutors. This is just how AI can help you practice your homework, help you understand your homework, help you prepare for exam, just how AI can help you in an educational space. um, I've been tutoring for over 12 years now. I paid my way through undergrad and I paid my way through grad school by tutoring, and once ChatGPT came along, it's a game changer. By all means, it's a game changer. I don't think it's going to replace professors. It doesn't have the ability to speak yet. It doesn't. It nothing beats really just going to class, but it has the ability to replace me as a tutor for at least 50% of you. If you're just looking for a little bit of help, a little bit of guidance, a little bit of practice, a little bit of reassurance, this is perfect for you. The free version or the paid version, either way, um, it's not cheating. I think like if it's helping you with your homework, homework is only usually worth 10, 15, maybe 20% of your grade, and it should be correct. And most of you cheat on your homework anyways. If you're gonna cheat, like, oh, we have 3 attempts, so after the first attempt, it'll just tell me how to do it, and da 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 da. So, or you do it with your friends and you just copy off the next person. Those people, they're just going to cheat regardless. So I don't think having or utilizing ChatGPT is going to change, or is there going to be any statistical difference of cheaters before and after? That's just how it's going to be, and that's not going to help you on the exam. This is also why I don't think online exams are definitely a math thing. I don't think you learn well with online exams for math, unless you can have somebody proctor your exam. But online exams for math, when you're just having to, do multiple choice or just doing a fill in, I think it's really a cop out for the professor or the teacher, because they don't want to grade or do any of the grading on the homework or the test. And that just does I think it just does a student a disservice. I really do. Math's about the process and understanding and seeing the steps. A lot of times I've noticed now, since they moved to online or to a more online based math, that the structure that people solve an equation, it is very difficult to follow. Very difficult. The equal sign doesn't carry all the way down. When you're just solving for x in a very complex equation, that flow looks weird. Now, it's because you don't get graded on the process, you just get graded on the answer or not, if the answer is correct or not. And don't even get me started with rounding issues. Rounding issues are a joke. Oh, do I round at the end? Do I round in the middle? And everyone's different and everything's different, and the number is going to be slightly off, and then you get it wrong. But I think when it comes to the rounding thing, that's why some math's a little bit subjective. I don't think you should get penalized for rounding in the middle or rounding at the end. Is the process right? Yeah. Sorry, it doesn't go out to 17 decimal points. But if you're doing a revenue function or you're doing a profit function, you just really care about the dollar. You're never going to get like when you're predicting something, you're never going to get as closest to the cent. Just put it in dollars and call it a day. It's just how it. Well, that's my rant for the day. This section here, we're going to talk about partial derivatives. Do a little x and y action. See how you could take a derivative with two variables inside, how to find the maximum or minimum. And we are going to be referencing systems of equations. So for that, check out the system of equation video, because we just skip right through it. If you need help with that, I do have one out there. I think it's called polynomials. I'll put the link down below. I hope everybody enjoys. Here we go. Okay, so on this part 4 of our derivatives, we're talking just about partial derivatives. We're going to have a normal, just easy partial derivative function that we just have to find df of dxy, or dx, derivative of our function with respect to x, and derivative of our function with respect to y. That is what that df over dx means. And we'll ask ChatGPT that too. The second one, as you can see here, is just doing the product rule with a product rule with two variables in there, x and y. And then the third one is finding maximum or minimum for a function with two variables in it. Let's see how ChatGPT can handle it. All right, so if you want to pause here, write any of these functions down. I'll put a link in the description below for these functions. So let's get started here. I uploaded everything, and it is wild. We're using just regular 4.0 ChatGPT, and I uploaded practice problems for derivatives. It told you exactly what the practice problems were for the first problem, and then it just solves them, which I always find fascinating. Again, it's very inconsistent. Sometimes it asks, what would you like me to do? And sometimes it just solves it, as you can see here. It went and it solved all of them, which is cool, but that's not very helpful for you at all. That's not very helpful for anybody that's still trying to learn the process. So first, let's see what ChatGPT does. Can you explain to me how to take a partial derivative or a derivative with an x and a y in there, similar to number 1? So let's just ask it just to see how it explains it. I did not add a question mark. That is my bad. All right, certainly taking a partial derivative of a function involving multiple variables such as x and y means you differentiate the function with respect to one variable while treating all the variables as constants. This is crucial in multivariable calculus, where function depends on one or more variables. Here's a step-by-step process breaking down problem 1 as an example with this function. So that is actually wrong. They didn't write it down. It should have been 2x squared y squared minus 3xy, but we'll get to that. Yep, didn't read it correctly. All right, that's fine. So understanding the function involves two variables, x and y. First, taking the partial derivative with respect to x. So it's saying that's what it is. All right, treat y as a constant. Imagine it's a number like 3 or 5. It doesn't change when you differentiate with respect to x. Cool. So with respect to x, for 2x squared y squared, differentiate 2x squared as if y squared was a constant coefficient. That is key. Therefore, the derivative of x squared is 2x, so multiplying by the constant y squared, we get 4xy squared. For negative 3xy, the derivative of x is 1, so the term becomes 3y. The constant term 5 disappears because the derivative of a constant is always 0. So it did the first derivative with respect to x, which is weird. It wrote it down incorrectly, but it took the derivative correctly. That's interesting. Taking the partial derivative with respect to y, and it shows what the df, because a lot of people don't know what that df dy means, and you can even ask it too. What does the df dy mean? What does that mean? The notation df dy typically refers to the derivative of function f with respect to y. This could represent either a partial derivative or a total derivative depending on the context. If f is a function of multiple variables, usually just a partial derivative of f with respect to y. So that's, oh look, sometimes you get through a lot of calculus and people don't understand what that dy over df is, or df over dy is, and ChatGPT explains it right there. It just denotes it derivative of f with respect to y. So then it took the partial derivative of that. Keys to remember: partial differentiation is about focusing on one variable at a time. Treat all other variables as constant. Apply the usual rules of differentiation, product rule, chain rule, as if you were dealing with the function of a single variable. Interpretation tells us how the function changes in the x direction and the y direction, respectively, at any point. So you kind of do it separately. This process allows us to understand the behavior of multivariable functions in complex systems by examining their changes in different directions separately. Great. Honestly, I wouldn't be able to explain it any better myself. That is actually cool. What if you're still kind of confused? I am still confused. Can you please provide me with another example? Absolutely. Let's consider a new function of two variables to illustrate the concept. So there goes a little bit simpler function. We're interested in finding how f changes with respect to each variable. So we have df over dx, and we have df over dy. The term y squared is considered a constant in this context, and its derivative with respect to x is 0, since y squared does not change when x changes. So a lot of people can get confused on derivative of 2xy. 2xy. The derivative of that with respect to x would be 2y, and a lot of people forget the y, like adding the other variable. That is something a lot of people are confused with. I am confused on how the derivative on, or can you explain in greater detail on taking a derivative with respect to x from 2xy squared. We'll just add a squared. So taking derivatives when they're multiplied, I call it a buddy. You just bring the opposite variable down like the coefficient. He says, let's see what ChatGPT says. I actually think I need to give this ChatGPT a nickname. I'm not sure what it is. If you have any ideas, comment down below. The term 2xy squared that identify variables and constants, and this term x is a variable with respect to which we are differentiating, and y squared is treated as a constant. Okay, apply the constant multiplication rule. So it's treated as constant, just like a normal coefficient. So you bring it down. Cool. So, and then apply the constant. Thus, the differentiate 2xy squared with respect to x, we treat 2y squared as a constant multiplier x. Result. All right, cool. Now, can you take the derivative with respect to y? So this is a tricky question. You normally want to be detailed. So because if I said now, can you take the derivative with respect to y? If I don't necessarily say the function, sometimes it doesn't work. It doesn't reference that function. So it's one of those glitches that it might just start from the beginning and start doing number one. So in this case, it doesn't look like it didn't. It says differentiate y squared, which is 2y. Cool, applying the power rule, which states, okay, apply constant multiple rule, so 2yx. the derivative of 2xy squared with respect to y, treating x as a constant, is 4xy. Good. Order doesn't matter, right? A lot of people, genuinely, it's okay. Why isn't it 2x to y? A lot of people think that's what it should be. But let's see what it says. I know what I would say. It doesn't matter the order. When you multiply stuff, it should still be just 2 times 3 times 4 is the same as 4 times 3 times 2 or 3 times 2 times 4. Order doesn't matter. Here's a breakdown of the term. Therefore, we differentiate. It says that again. The key point is recognize that x behaves as a constant and not 2x because we're applying the power rule and treating it. Okay, so let me rephrase my question. Didn't answer it. Why isn't it 2x to y? Why isn't the derivative of 2xy squared with respect to y not? I see where the confusion might be. It seems like there was a misinterpretation of the communication of the differentiation. Let's clarify it with the correct understanding of your question. When you're asking why the derivative with respect isn't 2x to y, it looks like you're correctly applying the differentiation rule, but aiming for clarity on the notation or simplification. And again, this is a common, it's a common question that I get asked a lot as a tutor. And it answered it really well. From 2, the 2y derivative multiplies with x and the initial coefficient resulting in 4xy. Coefficient 2. There it is, right there. The 2y times 2, the initial coefficient. Order doesn't matter. It appears you're understanding the process correctly. Perhaps the notation was a bit confusing. If we were to write it out as you phrase, aiming to keep closely with the steps. You differentiate y squared to get 2y. You recognize x as the constant multiplier, so it stays in the expression. The initial confusion might stem from interpreting how the constants and coefficients combined are presented. So when you mention why isn't it 2x, 2y, it seems you're correctly identifying the components of the derivative, but expecting a different representation of the multiplication. The standard way to simplify it would indeed be 4xy, as multiplication is commutative and associative, allowing us to combine coefficients directly. Perfect. Gives the answer right there. Excellent. So now let's go. Perfect. Thank you. Always say thank you. You never know if they take over. You always want to be nice. And just be nice to everybody else. Now let's move on to number 2 from the uploaded homework. I know this is not the norm. Professors don't normally hand out worksheets, but that's okay. What you can do is you can actually take screenshots of whatever website you're using when you're doing your homework. I do not advise this for exams. Homework though, to practice, to answer questions, you can take a screenshot of it and then upload it or copy and paste it. I think screenshotting it is a little bit better because when you copy and paste it, it's hard to get math notation, if that makes sense. There's like a math keyboard. That's one thing that they need to put in here on inputting stuff, especially if you have separate GPTs for math. There needs to be some type of math keyboard. Most of the other websites that have been doing this for a long time, not necessarily a GPT, but being able to solve or simplify expressions. There's websites out there that have been doing it for years. They have a keyboard or some type of math keyboard. Okay, so for problem 2 in your homework, we're tasked finding partial derivatives. Yep. Product rule and chain rule. Cool. finding dy dx, u, 2x squared, so it's derivative of the first times the second. This part does not involve that, because so they're breaking down each of them into two. As involves that, finding, we apply similar reasoning and just adjusting for x. So for problem 2, the partial derivative of the function r, the partial derivatives with respect to, this involves, so it just gives you the answer. Okay. Thank you for providing the answer, but can you provide me with a step-by-step solution for let's just put df over dx first. I recommend doing one at a time. ChatGPT can be a little finicky, so it might just it might just get a little bit overwhelmed and do too much. And as you can see here, sometimes when it'll if you ask too much, it'll overload. That's like it provides a lot of answers, so you're looking at everything, and it's just a lot. So I always recommend putting everything in parts. So identifying the components. Yep, we talked about the chain rule, and we talked about how to take a derivative with e. That was in our last video, so go ahead and check that out on how to do it. This one will just kind of go off, but we already know how to do that. It's differentiating u with respect to x. The derivative of 2x squared with respect to x is 4x. And since 2y squared does not contain x, it acts like a constant, and its derivative with respect to x is 0. So we talked about that. Cool. Combine using the product rule. Derivative of the first times the second, plus the derivative of the second times the first, as you can see there. Perfect. Okay, so then what does it mean to check the cross variable derivatives? What does that mean? Checking cross variable derivatives often in the context of functions of multiple variables involves calculating the mixed partial derivatives of given function. Okay, these mixed partial derivatives are denoted, okay, so that's like taking a derivative, the second derivative, so the first one was with respect to x, the second one was with respect to y. With respect to one variable, then you take it to importance. The significance of mixed partial derivatives lies in several areas. Symmetry of the second derivatives. Okay, so therefore the cross partial will always be equal. Okay, how to check? To check the cross variable derivatives for the functions, you would start by differentiating with respect to x, then differentiate f of that derivative. So it's a derivative of a derivative. So it's a derivative of a derivative using one variable first, then the second. So it's I like to check to see, because sometimes when you're first learning, these types of topics, you don't use the correct lingo, and that's okay. You develop it over time. So I like to ask it in a very layman terms way, and to see what it would tell me, and boom, it explains it right there. Now I want to see, can you show me the cross variable derivatives for number 2. So if you do the cross variable for both x and y, they should be equal, which I always find is a great way of checking your answer. So it's thinking. It's thinking for problem 2, the cross variable derivatives, mixed partial derivative function are, we've already done the derivative with respect to x, yield the same result. Boom. It did it. Theorem of that. Can you show me the first derivatives, then the second, to show how they are equal? So, yeah. What? Okay, I'll be there in a sec. Jeez. Show how they are equal for the function, and let's see, it'll calculate it. This professors will do derivatives like this to this, at least this difficult to show, to make sure you do. Again, this is very difficult to follow sometimes, and it is very difficult for ChatGPT to catch, I will say. So what it normally does, because there's a lot of things that can go wrong, so what it will do is just show you kind of like this of what the answers of each step is, and then you kind of have to, it'll be a lot of guess and check, or trial and error of, hey, I'm going to take a picture of my notes, and then it's, it doesn't read it quite correctly because there's a lot of e's in it. There's a lot of powers and a lot of pluses and minuses and all this. So it's better just to, you do the whole thing, you check, you have it, check your answer, and then you kind of verify each back and forth. And it showed here what the first partial is, and then it showed what the second. Excellent. Now let's move to number 3. Can you explain the steps that need to be taken in order to solve? Sometimes when you're doing problems like this, these optimization ones, the local extrema and maxima, you just want the steps, because we've already talked about calculating the derivative. And now when you're studying, you're like, all right, I can't remember the steps. So this right here is a great source of providing what the steps are. Find the first partial derivative, set the first partial derivatives equal to 0. Look at it, said take dh over dx and dh over dy, so both partials. This is also called the first order conditions. Okay, set the first partial derivatives equal to 0, find the critical points. You so solve the equation simultaneously to find the critical points. These points, okay, so usually the second derivative test will give you if it's a maximum or minimum. Determine the Hessian determinant at each critical point using this formula. Perfect. Should be equal. Interpret the results. It has a local minimum, and then it has a local maximum. So it showed that's the second. All right, perfect. The second derivative with respect to, it's still going, okay. Showed interpret the results, second derivative test, set the first partial derivatives equal to 0. One thing I would have added on step 2 is solving them using systems of equations. So you're either going to do elimination or you're going to do substitution, but some type of systems of equations. 2 unknowns, 2 equations, should easily be able to do it. Now it's talking about here the second partial derivatives of the determinant matrix are as follows: 6 and 4 is 24. At the critical point 2, 1, the determinant d equals 24, which is positive, so therefore it's a local minimum. Now the next question is, how do I know if the function is a local or global minimum. Sorry. Sometimes when you're typing in here, you get a little brain fart. All right, so determine if a function's critical point represents a local minimum or a global minimum. Another type of critical point, you can use several methods of considerations. Note that the critical point is local based off of the second derivative test. Here's how to further do it. So local point. So the second derivative, however, the test does not tell us whether minimum is global or local to the region. Point is less than or equal to the function of all other points. You determine if it's local minimum. You can consider the following. Examine the domain. If the domain is defined over all closed bounded, all right, analyze the function's behavior for unbounded domains, or if the function's behavior suggests it might not have a bound, analyze the limits. So just doing the limits and finding the domain. Application here for this function, the quadratic nature. Quadratic nature always means that it is a local and that the global is either going up or going down. Okay, it's just that it might have a parabolic opening upwards towards a shape in both x and y directions. This structure often implies that the local minimum could also be the global, because x and y move on the same critical linear regression. The value of h will increase. However, without bounds of the domain, this is an inference based on the functions form, not a strict proof. Because the domain could be, x and y could be, they all have to be positive if we're talking about revenue or whatever type of function we are talking about. Usually if it's revenue, profit, those ones, x and y, they're quantities, so they're going to be positive, and it could be a constraint because we can't have infinite amounts. So there are different things that can go into that type of characteristic of a global domain or a global maximum or minimum. Excellent. I hope you enjoyed part 4 of our derivatives. We are going to have part 5. That one's just going to be strictly application based. 3 different questions on when and where and why we're using derivatives. Click the like, click the subscribe. Don't forget to hit me up on X. I hope everybody has a great day. Peace.